As the arsenals of modern warfare keep moving into fascinating and uncharted territories at breakneck speed, one of the most intriguing technologies that keep captivating people's imaginations around the world is directed energy weapons. After centuries of relying on kinetic solutions that require a projectile to be launched into a target, the idea of having a focused laser beam or a microwave blast neutralizing it at unspeakable speeds and without the need for munition has proven mind-blowing. Despite the technology's promising nature, its developers have found one obstacle after another in their quest to polish it enough to be effectively used on the battlefield. But at least one of these obstacles appears to have been surpassed recently, as Lockheed Martin announced in January of 2023 that DEIMOS, their laser weapon system that will be mounted on a Stryker combat vehicle, has achieved the first light, meaning that the laser's optimal performance parameters align with the system design requirements. As such, it looks as though combat-ready laser weapons will enter the world's battlefields sooner than expected. Directed energy weapons, such as high-powered lasers, are the latest type of weapon system that offers significant advantages over conventional kinetic solutions. Such advantages stem from the unique properties of directed energy, which allow it to deliver precise, rapid, and scalable effects on the battlefield. One of the most significant benefits of directed energy weapons is their accuracy. These weapons can deliver a highly focused beam of energy that can be accurately aimed and adjusted in real time, providing the ability to selectively engage individual targets. As such, it is possible to neutralize threats with minimal collateral damage and reduce the risk of harm to innocent bystanders or non-combatants. Another advantage is their speed of engagement. Directed energy travels at the speed of light, making it possible to neutralize a target almost instantly. This allows a quicker response to threats, which can significantly improve the chances of survival for troops in combat situations and help mitigate the impact of surprise attacks. Unlike conventional munitions, directed energy weapons do not require any physical projectiles, as they don't have maintenance costs, resupply needs, and no risk of running out of ammunition. Moreover, they do not generate any harmful byproducts or pose any threat to the surrounding area, making them an environmentally friendly option. Weapon manufacturers working on directed energy solutions claim the future of warfare will likely be shaped by the increasing use of these weapons, which will provide military forces with a new level of precision, speed, and versatility on the battlefield. But despite the incredible features and the remarkable potential the technology has, its development has faced a rather bumpy road, and many experts are confident that the technology will bring its own set of significant disadvantages. While directed energy weapons offer many advantages over conventional kinetic solutions, there are also some disadvantages to consider. These include technical limitations, operational challenges, and cost concerns. That said, one of the primary disadvantages of directed energy weapons is their limited range. Directed energy weapons typically have a much shorter range than traditional weapons, such as missiles or artillery. This can limit their effectiveness in specific scenarios and make it challenging to engage targets at a distance. Laser weapons development has been significantly hindered by the limited range of the prototypes. Despite lasers being composed of focused light, and this light being able to cross vast distances almost instantaneously, the beam can be quickly dissipated by particles in the environment like smoke, dust, water, and clouds, making its operational range sometimes deficient. Another disadvantage is the weapon's high cost. Developing and producing directed energy weapons can be expensive, and the high price can make it difficult for some countries to acquire and deploy them. Additionally, directed energy weapons typically require specialized training and personnel, which can increase the overall cost. The development of highly specialized optics for laser weapons is particularly challenging, as the technology is extremely costly, and there's no full-fledged military industry producing the optics at the moment. It would all have to be built from the ground up. Finally, directed energy weapons can also have technical limitations. The technology is still in its early stages, and there's still much work to be done to refine the performance of these systems and make them more effective in real-world scenarios. Nevertheless, Lockheed Martin has made a major breakthrough by overcoming many of the technical barriers that were holding the technology back. and bringing its laser weapon system one step closer to operational service. Lockheed Martin's DEIMOS system is a cutting-edge technology that promises to revolutionize modern warfare. DEIMOS, which stands for Directed Energy Integrated Multispectral Optic System, is a high-powered laser weapon that delivers precise and effective devastation at the speed of light. According to its creators, it will be a game-changer in the military world, providing a new level of protection for troops and military assets. Lockheed Martin has constructed and carefully honed its new weapon to meet strict combat parameters that seek to make it effective even in an environment where laser effects could be diminished. The DEIMOS system is designed to operate in multiple settings, from the harshest desert conditions to maritime and urban scenarios. It is equipped with a multispectral targeting system that effectively tracks and engages a wide range of targets, including unmanned aerial vehicles, rockets, artillery, and small boats. In addition, the system is highly versatile and can be mounted on various platforms, including ground vehicles, ships, and aircraft. One of the key benefits of the DEIMOS system is its ability to respond rapidly to threats. The laser beam travels at the speed of light, making it possible to neutralize a target in a matter of seconds. This not only improves the chances of survival for troops in combat situations, but also helps to reduce collateral damage. In an unprecedented stride forward that sets a milestone for direct energy weapons worldwide, Lockheed Martin has successfully conducted its first light demonstration. The trial is imperative in determining the projected quality of the system's beam and evaluating the overall performance of the spectral beam combination, or SBC architecture. The results were highly favorable, as the laser and its complex optic systems were able to perform just within the range of the parameters established in the design phase of the weapon. The SBC technology showcased the expected performance in enabling the system's power to be adjusted while preserving the beam quality of each fiber laser. Lockheed Martin's breakthrough is a major step forward in directed energy technology and represents a significant advancement in modern warfare. The weapon demonstrated a strong potential to provide a new level of precision, speed, and versatility on the battlefield, and its upcoming deployment is expected to significantly enhance the capabilities of military forces around the world. Now that one of the most prevalent barriers these weapons had to face was broken down, the future of the groundbreaking technology looks more promising than ever, and Lockheed Martin and its DEIMOS system are positioning themselves at the forefront of a new era of modern warfare. Only time will tell if the incredible promises made by directed energy weapon developers translate into reality once they reach the battlefields at some point in the next 5 years. For decades, the military application of laser weapon systems has remained in the realm of science fiction, with only the sporadic experimental design being brought up. However, that is about to change. In the following years, laser weapon systems will become a reality that will forever transform the future of warfare. American weapons manufacturer Lockheed Martin is in the late testing stages of groundbreaking Tactical Airborne Laser Pod technology that will allow combat planes to intercept and destroy missiles, drones, and other dangerous projectiles at the speed of light. Releasing such a massive amount of focused energy would prove a game-changer for military organizations around the world, and many of them are already attempting to develop technologies to counteract the overwhelming devastation that the technology would bring. In the meantime, the addition of these laser pods to the U.S. Air Force arsenal represents yet another remarkable advantage in protecting American pilots, one that comes at the speed of light. Ever since light amplification was theorized in the early 1950s, its possible applications have captured people's imaginations around the globe. In the 1960s, the first experiments with light amplification were successfully conducted, resulting in the development of the first light amplification by stimulated emission of radiation devices, or laser. By using lenses, mirrors, and electronic technology, laser devices are able to focus light energy into a tiny spot in space, effectively amplifying the effect the light has on the target. As time went by, laser technology became more efficient and easier to produce, leading to the assimilation of the devices into a wide range of technologies, from presentation pointers, optical disk drives, laser printers, and barcode scanners, all the way to DNA sequencing instruments and fiber optics. However, despite the multifaceted applications achieved by laser technologies, its use as a weapon had long been limited to the pages and screens of science fiction stories, mainly due to power limitations. A vast amount of energy input is needed to go through a large-sized device in order to produce the minimal amount of focused energy to work as a weapon at a long distance. For instance, a conventional kinetic weapon is able to deliver about 1 kilojoule to a target when using a .357 Magnum round. Meanwhile, a laser functioning at 10% efficiency due to distance and environment factors requires 10 kilojoules of input energy to deliver the same 1 kilojoule laser pulse. Hence, laser weapons have been left to the side for decades as they were too resource costly and bulky in contrast to conventional armament. Another major issue that has staggered the development of laser weapons is the massive disadvantage they present to any environmental contaminant. To be 100% effective, a laser should be moving through a vacuum or through empty air, as particles from gases, smoke, dust, or any other polluting element will radically reduce the energy output the laser delivers to its target. Such a disadvantage means that something as simple as a smoke grenade could make a powerful laser weapon practically useless, as the smoke particles absorb most of the energy traveling to its target. Still, the significant technological advancements in laser devices have made it possible for the military to find potential niches for such amplified energy sources. And the main advantage of laser weapon systems over any other conventional means of armament is their unparalleled delivery speeds. Laser weapons channel light, so they can deliver their firepower almost instantaneously. This makes them highly valuable as interception weapons to reach high-speed projectiles that would otherwise be practically impossible to intercept in mid-flight. Lockheed Martin's laser technology has been in development for over 40 years, and they've managed to decrease its inherent disadvantages while enhancing the fantastic features that have captured the imaginations of generations. Although the corporation's laser solutions are still designed with limited applications in mind, they've reached a point where they're able to mass-produce laser weapon systems capable of defeating small rockets, unmanned aerial vehicles, small attack boats, and lightweight ground vehicles in a wide variety of environmental conditions. One of the first applications that will see the light of day is their Tactical Airborne Laser Pod, which was designed and developed to support a rapid shift to production and deployment, and eventually a transition to embedded systems. Mark Steven, leader of Lockheed Martin Missiles and Fire Control Strategic Technology Development efforts, stated, quote, "The Sniper Pod, it has lasers inside of it that have to be maintained onto a target during high-speed maneuvers in flight. So the technology and the algorithms we've developed over the last 40 years on those types of electro-optical systems with laser designators in them are directly applicable from a pointing and jitter control standpoint." As the technology stands now, it consists of an external pod capsule that houses the tactical beam directors and the focusing lens, along with the power generator. The unit can easily be attached to a wide variety of aircraft and can effortlessly be removed if a specific mission requires a different array of armaments. To function as envisioned by the weapons manufacturer, the laser pods must work in conjunction with several other tracking and threat detection subsystems. Still, the specific details about these additional requirements have not been made public by Lockheed Martin, but their functionality was demonstrated in a computer-rendered simulation that showcased the Tactical Airborne Laser Pod in action. In the video, a large Boeing KC-46 Pegasus strategic transport aircraft is seen providing threat detection support via a network of infrared sensors and tracking devices. The aircraft successfully detects 2 incoming projectiles, a surface-to-air missile launched from a naval warship and an air-to-air rocket deployed by an enemy fighter. The tracking information is relayed to 2 General Dynamics F-16C Fighting Falcons equipped with the Tactical Airborne Laser Pod as they successfully lock on to the incoming targets and fire their lasers to immediately disable both threats. So far, Lockheed Martin has not made detailed statements regarding the efficiency reduction rates of their Tactical Airborne Laser Pod systems when used in less than ideal environments. However, if they were able to drastically reduce the effect of gas particles on the laser's energy output, the results would be unprecedented. As laser weapon systems shift from the lab to the battlefield, military developers are eagerly looking for ways to develop and manufacture the specific materials and technologies that make high-powered lasers possible. One of the main obstacles left to overcome before laser weapons can be widely deployed is the creation of a robust beam director industry. The beam director is the optical system that puts high-energy light on the target and keeps it there with high precision. The ability to produce beam directors in large numbers at a low cost is crucial to the eventual mass production of laser weapon systems. Other critical components, such as optics that can sustain high-energy laser beams, have only been built in minimal quantities for prototypes and experimental technology. Massive investment is required in order to manufacture such components at total production rates and at lower costs. According to Mark Steven, the efforts to jumpstart the laser weapon manufacture industry are on their way. Quote, "We're making capital investments to be ready to manufacture key high-energy laser components at full production rates and low cost. We're investing over $20 million in our Orlando-based optical component center to expand the manufacturing footprint by 40%. It is clear that manufacturing setbacks are temporary, and once the production chain of components is established, the future of laser warfare technology will be unleashed, and the technology will be implemented in airborne, naval, and ground military systems." One of the significant factors that have contributed to securing American interests around the globe is the U.S. policy of keeping military bases in foreign territories. With no other nation in the world having as many military posts worldwide, the U.S. has been able to deploy its mighty military in ways no other country has been able to. But the policy has come at a price. U.S. military bases in other countries have caused more than their fair share of tensions and political controversies, and the U.S. has been forced to develop innovative ways to protect them without increasing diplomatic tensions. Enter the active denial system, a groundbreaking non-lethal directed energy weapon created by the U.S. military for area denial, perimeter security, and crowd control as safely and effectively as possible. As a hostile crowd enters the perimeter of the U.S. military, the mobile active defense system can engage large groups of intruders by emitting a beam of concentrated energy that immediately causes significant discomfort. Despite many considering it a technological marvel, controversy has surrounded the weapon, with an unfortunate incident in 2007 putting the entire project at risk. For decades, non-lethal crowd control solutions used by American law enforcement in the U.S. military have showcased several significant flaws that have resulted in tragedy. Conventional counter-personnel non-lethal weapons like rubber rounds, beanbags, and water cannons use kinetic energy to break hostile groups apart and dissuade them from advancing on a specific perimeter. However, kinetic-based systems present a significant risk of human injury, depending on the part of the body the weapon makes contact with and the environmental characteristics in a specific scenario. A rubber round might be mostly non-lethal by itself, but it can push an intruder off a tall structure. As such, the technology becomes harder to control. Additionally, the effectiveness of conventional kinetic solutions fluctuates drastically depending on the target's size, age, and gender, making it unreliable and prone to fatal accidents. If a kinetic weapon is designed to take a hostile male out of a battle unharmed, the effects could be considerably more severe if the same system is used against a female perpetrator. To make matters worse, most of the non-lethal kinetic perimeter enforcement solutions also display a minimal range, especially compared to lethal weapon systems. This resulted in military personnel being exposed to higher levels of risk to confront the threat. Thus, the U.S. military needed a non-lethal weapon system capable of offering much more control, more extended range and reliability, and as minor collateral damage as possible, especially when defending military infrastructure on foreign soil, politically unstable territories, and regions where they cannot rely on law enforcement support. Developing an effective system, regardless of size, age, and gender, and with a superior range compared to small arms fire, became a priority for the U.S. Defense Department. Soon, the solution would come knocking at their door. Military research around the globe has significantly focused on the development of directed energy weapons. From missile-destroying lasers to nuclear-focusing space beams to microwave crowd control devices. Such futuristic technology appears to be feasible enough to attract the attention of military investment. The premise is simple: generate significant amounts of energy, magnify it to be delivered to its target, and effectively neutralize it. The Active Denial System, or ADS, works by unleashing a high-powered 100-kilowatt beam of 95 GHz waves at a target and effectively heating its skin to a highly uncontrollable level while remaining non-lethal. The blast produced by the device is similar to the energy produced by a microwave oven. The main difference is that the waves deployed by the ADS can travel for very long distances while still providing enough power for successful deterrence. In 2002, an early version of the ADS was developed for the U.S. Advanced Concept Technology Demonstration Project. The scheme allowed technology innovators to swiftly build prototypes for emerging technology and demonstrate the concept to possible government investors and military manufacturers. The result was a rudimentary crowd control system designed for law enforcement and prison riot scenarios. The device had a minimal range, and it showcased numerous flaws and probable risks. Still, the demonstration was impressive enough to gain the attention of the Defense Department, who decided to invest in the project and further optimize the technology. In 2004, the U.S. Defense Department signed a contract for $6.3 million to develop a single optimized 95 GHz millimeter wave source system capable of providing perimeter denial for military infrastructure. With the backing of the U.S. military, the ADS system evolved swiftly. By 2005, advanced prototypes were ready for testing on human targets. The optimized ADS prototypes consist of a high-power linear beam vacuum tube array called a gyrotron that produces millimeter wave electromagnetic waves by cyclotron resonance of electrons within a powerful magnetic field. The electromagnetic waves produced by the device are then channeled through a flat antenna-like contraption that directs the energy to its intended target with an operating distance of up to 800 feet. 2 variations of the ADS were produced, and the technology prototype integrated the system into a high-mobility, multi-purpose wheeled vehicle. Meanwhile, the tactical version was built like an armored, containerized system transportable by military armored vehicles. Contrary to many rumors that have spread since its unveiling, the ADS does not use laser beams, radioactive materials, or wavelengths equal to that of a microwave oven. In fact, the system is designed to avoid causing permanent damage and radiation harm or skin burning. As opposed to the 2.45 GHz a microwave oven operates at, the ADS unleashes waves at 95 GHz, and the much shorter wavelength can travel longer distances while only capable of penetrating 1/64th of an inch of the target's skin, causing an overwhelming burning sensation but not delivering permanent damage. If the system unleashed energy on the same wavelength as a microwave oven, the heat would penetrate the target several inches deep, causing more damage to the receptors. The different versions of the ADS have undergone numerous tests and thorough assessments, and over 13,000 controlled exposures have been carried out with the help of volunteers, both in static demonstrations and in realistic simulations. An Air Force research laboratory member recalled his experience as a test subject for the ADS. Quote, "For the first millisecond, it just felt like the skin was warming up. Then it got warmer and warmer, and you felt like it was on fire. As soon as you're away from that beam, your skin returns to normal and there's no pain." Many other volunteers described being exposed to the heat ray as very similar to the temporary heat felt by opening the door to a hot oven. The sensation is strong enough to trigger a nearly instantaneous reflex action to flee from the beam. Of the thousands of tests performed on human volunteers, only 2 serious injuries occurred. The first case happened in January of 1999, when the ADS technology was still in its early development phase. In it, a researcher was exposed to a not yet optimized beam of heat, resulting in a quarter-sized blister that healed in a couple of weeks. The second occurrence took place in April of 2007, when an airman volunteer was injured during a training exercise, receiving second-degree burns from overexposure to the ADS due to human error and procedural miscalculations. The wounded soldier made a full recovery, but the event dramatically crippled the untethered development the ADS had enjoyed until then. Despite ADS researchers assuring that injury probability is as low as 1%, and that kinetic non-lethal weapons have a much higher risk of delivering permanent damage, many critics have questioned the technology after the 2007 incident, citing the long development and lack of deployment as a sign that there is something wrong with it. Other detractors point to the fact that the ADS can easily be turned into a severely harmful weapon if misused or in the hands of untrained personnel. Whatever the reason, the ADS has not seen any combat usage, despite being deemed ready for deployment since 2007. Only a few ADS units were deployed during the war in Iraq, but they ended up not being used, fueling its detractors' suspicions even further. For decades, the United States and other militaries around the world have been developing laser weapons that can be used against hostile targets to cause as much damage as possible. However, the U.S. Air Force has recently developed a unique-looking, state-of-the-art laser rifle that aims to do the contrary, and has been baptized as the Phaser, or Personnel Halting and Stimulation Response Rifle. The weapon has a laser sight that dazzles the targets and temporarily incapacitates them without causing any sort of irreversible damage or revealing the source. It is described by the United States Air Force as, quote, a rifle-sized laser weapon system that uses two non-lethal laser wavelengths to deter, prevent, or mitigate an adversary's effectiveness. Many people believe the rifle might have been inspired by the famous Star Trek franchise. Regardless, it honors its oft-heard philosophy, calls for the ship's crew to avoid any lethal engagement, or, as they put it, set phasers to stun. One of the Air Force Directed Energy Directorate's first laser weapon developments was Sabre 203, a state-of-the-art laser that was specifically fitted to an M16 assault rifle armed with a 40mm grenade launcher. Sabre 203 comprised two parts, a metallic capsule that shares the same shape and size as the 40mm grenade launcher and that houses the laser device, and a tiny control box that snaps onto the launcher's base. To use the laser, an operator first loaded the laser capsule into the 40mm tube as if it were a grenade. Then, he placed a battery pack on the M16's underside and snapped it. The operator then manually activated the laser with a button located on the battery pack, and it could be set in motion without interruption or pulsed to turn it on and off. Sabre 203 was easy to operate and handle under combat, where a soldier or marine could easily swap the capsule for a conventional grenade to fire against the enemy. During the American invasion of Somalia during Operation United Shield in 1995, U.S. Marines employed the laser with great success against the enemy as part of their nighttime operations. Sabre 203 then led to the development of BOSS, the Battlefield Optical Surveillance System. BOSS comprised an array of sensors, lasers, and optics that were mounted on top of Humvees and other American armored vehicles. A red or green laser was used to aim at specific targets before the soldiers could fire their machine guns. The Sabre 203 laser illuminator set the groundwork for what would eventually be the Phaser rifle. Blinding laser weapons have been banned since 1995 under the Protocol on Blinding Laser Weapons. Protocol 4 of the 1980 Convention on Certain Conventional Weapons was formally issued by the UN on October 13, 1995. Since then, over 109 countries have agreed to the protocol, and the United States acceded to it on January 21, 2009. The reason behind the protocol's adoption was to, quote, counter the silent and invisible threat to human sight posed by the threat of blinding laser weapons deemed to cause unnecessary suffering or superfluous injury. Article 1 from the protocol establishes that, quote, it is prohibited to employ laser weapons specifically designed as their sole combat function or as one of their combat functions to cause permanent blindness or unenhanced vision, that is, to the naked eye or to the eye with corrective eyesight devices. The high contracting parties shall not transfer such weapons to any state or non-state entity. However, based on Article 3, the protocol does not prohibit attacks against optical equipment such as periscopes, telescopes, and binoculars. Still, such attacks may also lead to human injury, and it is an ongoing issue. The Personnel Halting and Stimulation Response, or Phaser, has a laser light that illuminates or dazzles aggressors and temporarily impairs individuals and their ability to see the laser source. This innovative, non-lethal illumination technology was developed by the Scorpworks Laboratory Team, a research unit in the Laser Division of the Air Force Research Laboratory's Directed Energy Directorate at Kirtland Air Force Base in Albuquerque, New Mexico. The project's sole objective was to come up with what Kirtland Air Force officials have described as, quote, the first man-portable, non-lethal deterrent weapon intended for protecting troops and controlling hostile crowds. During a recent live weapons demonstration test at Kirtland Air Force Base, Captain Drew Gettler showed how the Phaser laser rifle operates. Members from the Air Force Research Laboratory's Directed Energy Directorate explained that the Phaser rifle was developed to neither fatally wound nor injure the intended targets. Instead, the weapon only temporarily blinds them to immobilize them without causing bodily harm. 2 prototypes were shown to the public before one of them was shipped to Texas for additional testing. Funding for this non-lethal rifle came from the Joint Non-Lethal Weapons Directorate and the National Institute of Justice, one of the most important organizations when it comes to using military technology for civil law enforcement. The phaser program has also received support from the Department of Defense, with the intention to mass-produce the laser weapon for police roles. Spokespersons from the Department of Defense have pointed out that the phaser rifle could be used to temporarily blind suspects who drive through a roadblock or any other situation in which non-lethal methods can be used to take down a target. Although it has never been publicly acknowledged, it is possible that the laser rifle's name comes from the so-called phaser rifle used by characters from the Star Trek science fiction franchise. In that universe's lore, the phaser is a portable energy weapon with two different firing modes. One can fatally wound a target, while the other can strike living organisms with non-lethal effects that temporarily incapacitate them. Despite the little information that has been shared by the Air Force and the Department of Defense, some experts have explained how the phaser laser rifle works. First, it incorporates a unique power source that makes the weapon completely self-contained. Second, it includes two low-power diode-pumped lasers, one visible wavelength and one mid-infrared one. Despite the many innovations of the phaser rifle and its supposedly harmless characteristics, many are still doubtful. During an interview with Will Knight from New Scientist, Tobias Feakin, an expert at Bradford University's Non-Lethal Weapons Research Project in the United Kingdom, said, quote, "In the past, the problem with lasers of this type has been that they often permanently blind human targets. This new wave of low-intensity laser weapons does not have a permanently damaging effect, apparently." Other global agencies currently working on weapons of the same nature have shared similar concerns. Some laboratories have conducted studies that have shown that even lower laser systems can lead to irreversible eye damage if they're used at close quarters for extended periods of time. Other experts that have worked with similar projects have claimed that phaser may attempt to address these safety concerns by automatically sensing the target from a safe distance. This eye-safe rangefinder may help the operator adjust the laser's power according to the target's location. This is also where the two-wavelength laser system may come in handy to counter goggles that can filter specific wavelengths of a laser sight. The Air Force and Scorpworks are hard at work testing the laser weapon to ensure it complies with United Nations directives. And in order to license the phaser rifle, the Air Force would have to prove that it is not harmful to the eye and does not lead to permanent damage.